So, welcome students in the series of the lectures that we are conducting for the chapter geometry. So, we have already gone through most of the things. At the very end we are left with say x radii and distance between special points. X radii in last class we discussed. I hope you remember in last class we said we formed x radii. So, x radii we wrote as r1 is delta by s minus a is 4r sin a by 2 cos b by 2 cos c by 2. This is what we read. I hope you remember from our last class. Further, similarly, you have r2 as delta by s minus b, that would be 4r sin b by 2 cos c by 2 cos a by 2, and similarly r3. Four r sin c by 2 cos a by 2 cos b by 2. Okay. R, I am absolutely sure you remember the general formula of delta by S, and for a triangle it is R, as we have already gone through. Delta by S is a universal formula, that is any polygon having an in radius is the in radius is delta by S. Fine. Now, some relations between R1, R2, R3 and R. One relation that is very useful is that 1 by R1, 1 by R3 is equal to 1 by R. Okay, you can simply see to it S minus A plus S minus B delta. So, 3S minus A plus B plus C, which is 2S, this is 1 by R. So, this is one relation that holds for R1, R2, R3. Another relation that holds is 1 by R1 square plus 1 by R2 square is A square plus B square plus C square by delta square. You can see this is S minus A whole square plus upon delta square. So, what does this become? 4S square minus 2 times upon delta square. Fine. 2S is A plus B plus C. So, this is also 2S. This and this gets cancelled out and you get the desired result. Yet another relation which I feel one can remember is R1 plus R2 plus R3 minus R is 4R. Okay. So, since you have to find 4R, it is better that we use this expression R1 plus R2 plus R3 minus R. Okay. So, R1 plus R2 you have cos C by 2 common, R3 minus R you have sin C by 2 common. So, R1 plus R2 is 4R cos C by 2 into sin A by 2 cos B by 2 plus sin b by 2 cos a by 2. So, R1 plus R2 is 4R. This is sin a by 2 cos b by 2 plus sin b by 2 cos a by 2. This becomes sin of a plus b by 2, which is cos c by 2. So, 4R cos square c by 2. R3 minus R, you have 4R sin c by 2 as common, and then you have cos a by 2 cos b by 2. Cos of a plus b by 2, which is sin c by 2. So, this is 4R sin square c by 2. So, R1 plus R2 plus R3 minus R is 4R. This is one thing that may on occasions be needed. Okay. Now, say somebody asks you to say for my equation for a cubic equation whose roots are R1, R2, R3 and R. So, R1, R2, R3, sorry, that will be 4-degree equation. So, R1, R2, R3. So, x cube minus R1 plus R2 plus R3 into R into x plus R1, R2 minus this we write as 4R plus R, just from our previous question that we did. This, if you remember, here we can use R1, R2, R3. We can write this as R1, R2, R3 into 1 by R1 plus 1 by R2 plus 1 by R3, which is 1 by R. So, R1, R2, R3 you can say is S minus A, S minus B, S minus C upon delta Q. Sorry, I wrote it just the other way around. One is not, very sorry. Delta cube by S minus A, S minus B, S minus C. This gets, it is S delta, delta S. So, the equation becomes, this is delta S upon R. R you can write as delta by S. So, it is S square. So, the equation becomes x cube minus 4R plus R into x plus S square x minus product we just saw as S delta. Okay, so this is the equation whose roots are R1, R2, R3. On occasion somebody may give you and then ask you about the triangle, give you this relation and ask you about other things in the triangle. Fine. Now, you may be given information regarding this, but primarily what is of help, as I have been constantly conveying you, is that these relations are just that they are there. They are generally not required directly. We must know the working how to get to them, followed by some manipulations, but it is always to be preceded by the basic steps. We must know how did we reach to this point. Okay. Now, let us discuss a triangle whose vertices are the excenters. A triangle whose vertices are excenters of the triangle. Okay, it is called excentral triangle. So, if this is a triangle, say, if this is the triangle, let me and suppose I draw its internal and external bisectors. The diagram may not be properly drawn. Say something like this. So, this is our triangle. These are excenters. It is not drawn properly, but so be it. Now, these are internal angle bisectors. So, this angle is 90 degree, this angle is 90 degree, this angle is 90 degree. So, this point I is orthocenter of I1, I2, I3. Okay. Further, if you see further, if you want to know sides in terms of say ABC, so this angle is, we have to find these angles. This angle is pi minus b by 2, so this angle is b by 2 and this angle is c by 2. So, angles of this triangle are b plus c, that is pi minus a by 2, pi minus b by 2, pi minus c by 2. These are angles of this triangle. Insofar as sides are concerned, so this is say R1, okay. This is R3, and similarly this is external angle bisector, so this will again be b by 2. So, what is side I1, I3? What is I1, I3? If you write it, say I1, I3 is R1 upon sin b by 2, isn't it? This is hypotenuse, plus R3 upon, this is, no, R1 upon cos b by 2, R3 upon cos b by 2. So, what is R1 upon cos B by 2, 4R sin A by 2 cos C by 2, sin C by 2 cos A by 2. So, this is 4R that is 4R cos B by 2. Okay. So, this is the sides are 4R cos A by 2, 4R cos B by 2 and 4R cos C by 2. Instead of results, we must know the working. Okay. Results are rarely directly asked for. We must know how did we arrive at them. Further, in radius suppose somebody says what is the circumradius? So, A by sin A is 2R. So, you can say R1 is 2R. For I1, I2, I3, ABC is the triangle which is formed by foot of perpendiculars. Okay, and you can see these two angles are equal. So, I1, I2, I3 is excentral triangle of ABC, and ABC is called orthic triangle of I1, I2, I3. And it is a special pedal triangle. Okay. Very, very important information that must be known is that suppose we a light ray comes along this line, after getting reflected by I1, I2, it will move like this. Angle of incidence is angle of reflection. After getting reflected at this point, it moves like this. So, it reaches this point. So, this is the triangle with least, again I am saying, this is the triangle with least perimeter whose vertices are on sides of the triangle. Okay, because light ray travels along a path so such that it covers the least possible distance. Angle of incidence is angle of reflection. Okay, see what I am trying to convey is that suppose you are given a triangle and you are being asked to find the points on this triangle, one on each sides of this triangle, such that the perimeter of the new triangle that you form is least. So, what we do is that we draw altitudes and then we say this is the triangle with least perimeter. This is the triangle with least perimeter. It is called orthic or pedal triangle. Pedal triangle is, see, for pedal triangle, from any point if you draw perpendiculars to the sides and join this is called pedal triangle with respect to this point P. So, this orthic triangle is nothing but pedal triangle with respect to the orthocenter. Okay. Now, If you want to know sides, if we have solved this one, I think from here we can conclude what are the sides of pedal triangle. So, this is, I think the side angle came out to be pi minus a by 2. Okay. So, this angle is pi minus a by 2. Okay. If this is excentral triangle, if this is a, this is pi minus a by 2. Okay. So, if this is theta, this is pi minus theta by 2 is a. Okay. So, theta is pi minus 2. So, angles are pi minus 2a, pi minus 2b, pi minus 2c. If this triangle has circumradius r, orthic triangle has circumradius r by 2. So, sides are 2r, which is r sin pi. This is r sin 2a, r sin 2b and r sin 2c. Okay. And what is the circumradius is r by 2. What is worthwhile is remembering this much. देखिए ना, the orthic triangle is a triangle whose sides are, sorry, whose vertices are the foot of perpendiculars drawn from vertices to the sides, and this is the triangle whose vertices lies on sides of the given triangle, with the new triangle having the least possible perimeter. Okay. This angle being this equal to this angle ensures that. Okay. So, please keep this thing in mind. This is on occasions helpful even in this year's ISI. The question was asked that so that for every acute angle triangle there exist points on the sides such that if a ray of light starts from a point, after getting reflected by the other two sides, reaches the same point. That simultaneously also ensures that this is the triangle with least possible perimeter. Okay. So, there are ways to ask the same question. Some details that we must know of some of the triangles, some of the special points, the distance of orthocenter from sides in an acute angle triangle, distance of orthocenter from sides and vertices. The diagram is being drawn for acute angle triangle. So, this side is C, this is C cos B, we need this angle. Okay. This is C. What is this angle? This angle is C, 90, 90, this is C. So, you can say CH, sorry, BH upon C cos B. is equal to 1 upon sin C. So, what is BH? C is 2R sin C, 2R cos B. Sin C gets cancelled. So, this is 2R cos B. So, this is base, this is 2R cos B cos C. Fine. So, this is the distance of orthocenter from the sides and vertices. From vertex, if you want to remember, it is simple. From vertex A it is 2R cos A, from vertex B it is 2R cos B, from vertex C it is 2R cos C. And from side BC it is 2R cos B cos C, from CA it is 2R cos C cos A, and similarly. Okay. Now, moving ahead, this result will be helpful if you want to prove this. See, we have used the result that circumcenter centroid orthocenter are collinear. And OG is to GH is 1 is to 2. So, one way in trigonometry we establish it is like this. Suppose you draw a triangle, say this is altitude, okay. This is our orthocenter. Midpoint. This is midpoint. Above it will be our O. AM is the median. Now, you can very carefully see what we say is that let OH meets median AM at P. We have to show that P is nothing but centroid of this triangle. So, how do we go about it? This is 90. So, this will also be 90. This is 90 because this is perpendicular. AH we have just calculated as 2R cos. OM. Now, in a triangle, this angle is A, this is also A. So, at the center, this is R. So, what is this? This is R cos A. These two are parallel lines, and this angle is definitely equal to this angle. So, these two are similar triangles. So, OP upon PH is AP, sorry, is PM upon AP is OM upon AH. So, what is OM upon AH? Half. So, P P divides MP in the ratio 1:2. Hence, P is centroid of this triangle. So, P is centroid of this triangle. This is what we had wished to establish. Simultaneously, we have proved that this is the centroid and this ratio is 1:2. A very pertinent and useful result. You will see that it is used very often. Lot of times this is of great help. So in, not only in geometry, but also when you go through coordinate geometry. Okay. So, I am not feeling well today. So, let us pause at this juncture. In next class, we will take a little longer session, so that whatever was left today is covered and we are at the end. So, next class may probably be our last or second last class. So, thanks a lot for looking at this, and I hope this session would have been of some use and would have been helpful to you. Thanks a lot.